the error cone, or the cone of uncertainty, or the cone of death, as some people call it, this cone. We talked earlier about the skinny black line. The skinny black line is the exact forecast. If the forecast is 100% accurate, we don't want to ever assume that. It's never going to be 100% accurate. So there's the skinny black line in the center of the diagram, and there's that cone of uncertainty, that area of white that surrounds that skinny black line. And what the cone of uncertainty means is that looking back over the past, 2/3 of all storms that followed a track like the one shown here, like the forecast track, have fallen inside of that cone of uncertainty. So that's the most likely impact area. Don't focus just on that skinny black line, but be aware if you're anywhere within that cone of uncertainty, you could have an impact. And the impact and within that cone that's the center of the hurricane, not the impacts from that hurricane. So the center of that hurricane, when I say the far right-hand side of that cone, that white cone, there's going to be significant impacts along the western coast of Florida, maybe even in Orlando. That's the center of the hurricane. Not the impacts from the hurricane, but the center of the hurricane. The impacts extend beyond that white cone. So how do we determine the white cone? We do that by looking at the average forecast error at each point in time. So 12 hours, 24, 36, 48, 72, all the way up to 120 hours in the future. We know that based on past performance, what the average error is for hurricane. And we create those circles, and then encompassing those circles, we draw that white area. So that's where that skinny black line and the error cone comes from. Let me back up and show you that one more time. There's the skinny black line, there's the error cone, and the error cone is determined or defined by these individual radius around the forecast points, from 12 hours all the way up to 120 hours in the future.
One issue I've always had with forecasting is that you're allowed to change it once you establish it. That seems like you're cheating. I know why you do it.
Right.
I've seen in the past where that has shifted dramatically from one day to the next. So,
Yeah, because since it's based on the forecast, individual forecast points in each time period, if the forecast track or those forecast points shift, that whole cone of uncertainty is going to shift too. And one thing we try to do is be as consistent as possible. So if we see, if we get that forecast, and all of a sudden we have new guidance come in 6 to 12 hours later that's showing a dramatic shift in where the hurricane's going to go, we don't automatically commit to that right away. We evaluate unless it's very close to the coastline. We evaluate that, we try to determine is this maybe some figment on the model, or 12 hours from now it's going to shift back. So the last thing we want to do is go with this forecast, and then 12 hours later show a threat to Tampa, and then 12 hours later shift it back to the Gulf and don't show a threat to Tampa. So we try to show some consistency in that.
One quick question.
Yes.
It's not meant at all to be political, but I've just heard in the last couple of days something that would affect this error deviation a lot that has to do with funding that's being given to the National Weather Service for being able to utilize weather satellites, if I'm not mistaken, for that error deviation. Can you address what is looming here on the horizon?
Yeah, that's as much unknown for us as it is for you. It is all federal budget based. So for weather satellites and for hurricane reconnaissance flights, it's all tied to the federal budget year to year. We've heard recently that Congress is very much in favor of funding the next generation of weather satellites to replace the generation that's up there now. If they didn't do that, it'd be likely probably 3 to 4 years from now there could be a gap until we get another satellite up into orbit to cover the Atlantic Ocean. There's different things that can be done. There's other satellites that are further west that can be moved further east in the hurricane season to cover the area temporarily. And there's some things that can mitigate that to some extent, but it really does come down to congressional funding. But the last thing we heard was favorable, that Congress was in favor of the next budget funding the next generation of weather satellites.
Prospect for us moving back to the dark ages on this thing.
I don't think back to the dark ages. I think there are mitigations out there from other satellites. We can share data with the European weather agencies. They can move their satellites from Europe or the west to see parts of the Atlantic. So we've done that in the past, and there's been a little bit of data gap. So it certainly is a very important issue because we want a very dependable satellite out there that can be there 100% of the time. But if not, there are movements that can be made to mitigate that and temporarily.
And one last question about this. For those of us that don't have the stomach to want to be following and stuff about what's going on in Congress at this very moment, we'd just like to get to the heart of that issue. Is there anything on your website that would address if there was any sort of unfavorable acts there or not?
There are on a local website, but there are on the NOAA website and the National Weather Service headquarters site. I can get that information to you later if you're interested in that. Definitely. All right, so just sticking with the point we made earlier, this is the cone of uncertainty again. We're going to back out and look at a different example now. This is, most of you probably remember, Hurricane Charlie back in 2004. So this was a hurricane at the time. It was located south of Cuba. There's the hurricane force winds in red, the tropical storm force winds in the blue radii south of Cuba. And on the left-hand side, if you can make it out, that the dotted line on the left-hand side is at this point in time, that's where the Hurricane Center, the National Hurricane Center, had the track of that center of NOAA. So that's the skinny black line. To the right of that, the other line that cuts across Central Florida is where the hurricane actually moved. This was the cone of uncertainty at the time the hurricane was located south of Cuba. So if you don't focus on the skinny black line, we all do that, but if we don't focus on that, and instead focus on the cone of uncertainty at this time, the cone of uncertainty extended from southwest Florida all the way up to northwest Florida, and everywhere from, say, Orlando to Cape Canaveral up to Jacksonville. So people that were along the southwest Florida coast and said they weren't prepared for a hurricane, that's just miscommunication. We haven't done our job very well explaining what a hurricane threat is, or the media hasn't done very well to explain that information, because everyone within that cone of uncertainty should be prepared for the possibility of a hurricane impacting their local area. The hurricane warnings are shown there in red, from the Florida Keys all the way up to north of Tampa Bay. So if you're in a hurricane warning, you should plan for the possibility of hurricane conditions, whether you're in Tampa Bay, Punta Gorda, or down across the Florida Keys. You're all within that risk. So look at the skinny black line, be aware of it, but don't make your plans based on that solely, please. When we do put out a hurricane warning, we have to allow for the uncertainty. We do this every time we issue a warning for hurricane. So let's look at a perfect example, first of all. Let's look at the upper coast of Florida. The area there is shown in yellow is the radius of the hurricane force winds. That's the current time, right now. Let's say we could make a perfect forecast. And the forecast goes right down here during the center line, makes landfall around Charleston, South Carolina. And the size of the storm is exactly right. So the current size of the storm doesn't change. It comes on shore at the same extent of maximum winds. So that circle that right in the middle there impacts the coastline will be the extent of the hurricane force winds. So if we could make a perfect forecast and we had 100% certainty that we could do that, we could put out hurricane warnings just encompassing that middle circle as it affects the coastline. Basically just the coast of southern South Carolina. But we know what the average error is. So we account for that average error right and left of the track. We build that into our hurricane warnings along the coastline. So in reality, for a situation like this, the hurricane could deviate north or south of that exact forecast. And in which case, the hurricane warnings are in effect from Jacksonville all the way up to the southwest part of North Carolina, a much larger area. An area about 3 times the size. So what does the hurricane warning mean? Does it mean we expect hurricane conditions everywhere in the area shown here in red? No. It means we expect it somewhere within the area shown in red. We just don't know exactly where because of the uncertainty. And we try to make that point, we stress that point every time we make a hurricane forecast. Is anywhere within that area of red, you plan as if the hurricane's going to come to your area. Even if it's forecast to hit Charleston, it could hit southwestern North Carolina, or it could even hit extreme northeastern Florida in this particular situation. So you prepare the same, you're ready to evacuate, and you've got all your preparations ready to go. But what this also means is that 3 times out of every 4, when you evacuate the coastline for a hurricane threat, you're going to go back home afterwards, and you're going to say, maybe I shouldn't have evacuated. It doesn't look like there was significant damage here. There was a storm surge, there's not a lot of trees knocked over, it wasn't that bad here for the storm. So what that sets up is the impression of people saying, okay, I evacuated 2 or 3 times recently, I'm not going to evacuate next time. I'm under another hurricane warning. I'm not going to take the chance and it costs me money, it costs me time, I have to leave my house. But it's just the uncertainty of hurricane forecasting. Is that about 3 times out of every 4, your particular area may not be impacted by those significant hurricane conditions. But somewhere within that area of red is going to be. Okay, hurricane intensity forecasts. Now to compare this with what we just showed for hurricane track forecasts, let's look at intensity forecasts over the last couple of decades. For 1 day, 2 day, 3 day, intensity forecast is shown in red, green, and orange here. If you look across the last couple of decades, basically that trend is a flat line, meaning little improvement of hurricane intensity forecasts. If we just take a snapshot, an average of the early 1990s, based on compared to the last 5 years, for 1 day, 2 day, and 3 day forecasts, there really isn't much difference. Maybe 1 knot or 2 knots of a difference. So in some cases, it's actually a lessening of accuracy. So we know this is our biggest forecast problem. We have a pretty good feel on the forecast track, but we still don't have a great feel on the intensity of a hurricane. So if we say a hurricane category 1 expected to come and make landfall, we tell emergency managers to put their plans for category 2 into effect, just to be safe, just to give a little extra cushion on top of that. It's a very basic rule of thumb, but it's the best we can do at this point in time. So intensity forecasts are not very accurate. One thing we're always worried about is when hurricanes coming in to make landfall, the hurricane may be developing rapidly, maybe that last 12 or 24 hours before landfall. So maybe you're preparing for category 1, you're going to bed at 10 o'clock at night, you're going to get up first thing in the morning and assess what's going on, decide if you're going to evacuate the coastline or not. You wake up the first thing in the morning, and all of a sudden now the hurricane's in category 3, and expect maybe to intensify a level lower to category 4. Now, everything has totally changed from what you heard 12 hours earlier. And this is just a reality of the hurricane forecasting for intensity. One thing we're doing to try to improve this is aerial reconnaissance, or hurricane reconnaissance. The U.S. Air Force does hurricane reconnaissance from Biloxi, Mississippi. They typically fly at 10,000 feet. They have a crew of 6, and their missions are about 11 hours on average. The National Hurricane Center has at their disposal some aircraft as well. NOAA, my parent agency, National Weather Services parent agency, also has Hurricane Hunter aircraft. We have 2 of the P-3 aircraft shown at the top and 1 G-4 aircraft shown at the bottom. The P-3s fly through at 10,000 feet, do a low-level investigation of the storm just like the Air Force does. And the G-4 flies at 45,000 feet above and around the storm to get the environment of the storm, the steering patterns. They get fed into the computer models to hopefully improve the hurricane models, tell us what's going to happen days in advance. And just recently, the National Weather Service, NOAA, in partnership with NASA and the Department of Defense, have begun an unmanned aerial surveillance project using the Global Hawk. And this is very similar to what the DoD is using out in the war zones of Afghanistan and Iraq these days to do surveillance on the enemy. We're doing surveillance on the enemy hurricane. And we're using this aircraft to fly. It's 44 feet in length, has a wingspan of 116 feet, 15 feet high, weighs 25,000 pounds. It can have a payload of weather balloons. Weather balloons we typically release from the ground and they go up. In a reconnaissance aircraft like this, the balloon is released out of the aircraft with weights and can be sent down to the ocean surface and gets the conditions from flight level of 10,000 feet down to the ocean surface. And it can stay airborne for 30 hours, can range 11,000 miles, flies 400 miles per hour, has a ceiling of 60,000 feet, so it can go way up in the storm. Right now, they're being flown at the high altitudes. In the future, we're going to bring it down to middle altitudes and maybe eventually to lower altitudes to collect data. But right now, we've been flying at high altitude. We can drop those weather balloons and get data from that point all the way down. You get a profile from that flight level down to the sea surface below. The cost of the aircraft is about $35 million. So I believe NOAA has 2 of these. If we were to lose one of these in a hurricane, the program would probably over. So hopefully we don't lose one of these aircraft in the program. But they are flying and will be flying this year as an experiment.